Hello guys, welcome to online chemistry course. In this video we'll talk about Gay-Lussac's law of combining volumes. Well, obviously, as the name indicates, it was proposed by Gay-Lussac. Okay, it was proposed in 1808 and was one of the prominent guys who worked with gases. We also see that in states of matter. Okay, in gaseous state actually. So the statement goes like this: when gases react together or produced in a reaction. Alright, so when gases react together or produced in a reaction. So if you look at an example here, alright, so let's see, you have H2 plus O2 and this will give you H2O. Alright, so let's say H2 is a gas, we know that. Oxygen is also a gas and water is also a gas. Alright, it's a vapor pressure basically. So if you balance the equation, you get 2. This is going to be 1, and here also you're gonna get 2. Alright, so in this case what he's saying, that when gases reacts, okay, together, or when the gas is produced, so this is what the gas that is produced, then they do so in volumes, okay, which bear simple ratio of one another, and okay, not just with each other, they do so in simple ratios also with the volumes of products. Okay, so that is the statement. So when the gases react, we already understood that when the gases reacts or produced in a reaction, they would either react in volumes in which they have a simple ratio of one another. Okay, so here if you look at the ratio of hydrogen and oxygen is 2:1, so they will always react in a simple whole ratio. All right, or when the gas is produced, okay, then it will be the volume of the product is also going to be a simple whole ratio. So if you look at that, so 2:1:1, so the whole stoichiometry of the reaction is 2:1:2. Okay, so that is essentially law of combining volumes. This was proposed by Gay-Lussac. All right, so again, make sure that you understood the statement. Here it says that when the gases react or produced in a reaction, they do so in volumes which bear simple ratio of one another. So when the gases react, they will always react in a simple whole ratio of one another. And if the gas is also produced, okay, if so here this needs to be, the product needs to be gas too. Okay, if the product is a gas, then the gas that is produced will also be a simple ratio of the reactant. Okay, and that's what we get. If you take another example here, let's say H2 plus Cl2, you're gonna get 2HCl. Again, H2 is a gas, Cl2 is a gas, and HCl is also a gas. If you balance the equation, it's already balanced, you don't need to do anything anymore. Here we have 1 of H2 and 1 of Cl2, and it's going to give you 2 of HCl. So the ratio is 1:1:2. Again, if you look at it, this is a simple ratio, multiple ratio of either of these gases. Okay, Another example would be if you take N2 plus 3H2 and you get NH3. Okay, you're gonna have 2 there, so now the equation is balanced. In one of the next another classes in the coming class we'll see how to balance the equation. It's pretty simple actually. Again, nitrogen is a gas, hydrogen is a gas, ammonia is also a gas. If you look at the ratio, 1 is to 3 is to 2, so the ratio is 1 is to 3 is to 2. Okay, that is a simple whole ratio because everything in this equation and in this equation is a gas, so they will always have a simple whole ratio. It will never be a fraction. Okay, so that concludes the law of chemical combinations, right? So we've discussed pretty much 5 laws. We discussed law of conservation of mass, we discussed law of multiple proportions, we discussed law of constant proportion or definite proportions, we discussed law of reciprocal proportion and law of combining volumes. And law of combining volumes actually applies to gases, okay, not to the solid, not to the liquids, but the gases. And if the product is not a gas, let's say for example, so in this case of water, right, it could be liquid. If you're doing the reaction at room temperature or lower temperature, this is going to condense into liquid, then it is not going to be applicable because the volume of the liquid is going to be different. Alright, so then that is not going to be applicable. So the law of combining volumes is only applicable when applicable to gases. Okay, so what are the constituent that are taking part in the reaction? Only if they are gases, only then the law would be applicable. It would not be applicable to if one of the thing is either liquid or a solid. All right, thank you guys. Please subscribe if you like the video. Bye bye.